Hello students, we're solving a question on kinematics. This is from 28th January, shift 1, JEE Mains 2026. The question says, a particle of mass m falls from rest through a resistive medium having a resistive force of F equal to minus kV, where V is the velocity of the particle and k is the constant. Which of the following graph represents the velocity versus time graph? So, here there is a particle which is falling in a resistive medium and the resistive force acting on it is minus kV, where V is velocity. If it's velocity, it means that whatever will be the direction of velocity, the direction of resistive force will be opposite to that. Let us say initially it has no velocity, right? So it will just start falling downwards due to mg and it will gain a speed velocity v downwards. Then the resistive force kV will act upwards. So if we apply Newton's second law of motion, mass into acceleration ma is equal to downward force mg minus upward force kv. So now what I'll do is I'll write acceleration as dv by dt will be equal to mg minus kv as it is. I'll divide the entire equation by m. So we are going to get dv by dt is equal to g minus kv by m. And then I will rearrange the terms. I'll bring the v terms together. dv divided by g minus k by m into v is equal to, I'll bring dt to the RHS. Now, if I consider at t equal to 0, the speed of the particle was also 0. And some general time t, the speed of the particle will be v. If I perform the integral, we have a linear function in the denominator. Integral of dv by g minus k by m into v will become ln of g minus k by m into v divided by minus k by m is the coefficient of v comes out in denominator. Now if I do upper limit minus lower limit, it will be log b minus log a, which I have directly written as log b by a. So upper limit gives you g minus k by m into v. Lower limit gives you g minus k by m into 0, which is g minus 0. So now if I do g minus k by m into v divided by g, I'll simply get 1 minus kv by mg, right? And I can cross multiply this to the RHS. This will become minus kt by m. If I rearrange the term and send ln to the RHS, if I send ln to the RHS, it's going to become e power minus kt by m. Then if you rearrange the terms, you'll get the velocity structure to be something like this. It will be mg by k into 1 minus e to the power of minus kt by m. We have seen this type of a function. It's going to be a saturation kind of a graph where the velocity starts increasing, but as t tends to infinity, the velocity is going to attain a saturation or terminal value of mg by k. So mg by k line will be asymptotic to this graph, right? So the graph should be something like this. As time tends to infinity, the velocity becomes asymptotic to the line mg by k. So this obviously matches with option 1. So option 1 is the answer.